Let's take a second look at the difference quotient. Remember, the difference quotient is simply the slope between 2 points on a graph. So if we consider the graph of f of t, an alternate formula for this difference quotient is f of t minus f of a over t minus a, being careful not to divide by 0 by making sure that t is not equal to a. So the points on the graph of f that we're considering are t f of t and a f of a. Our difference in y values is f of t minus f of a, and our difference in x values is t minus a. So let's look at the example of f of x equals x squared plus 2x and find the difference quotient at a value of a equals to 1. So we need two pieces of information here to substitute into our difference quotient. We need f of t and we need f of 1. So f of t is simply taking this function f and putting a t in everywhere we see an x. So that is t squared plus 2t. So we're just writing our original function with a different variable. F of 1 is an evaluation of that function, so everywhere I see an x, I'm going to place a 1. So I get 1 squared plus 2 times 1, which is 1 times plus 2, which is equal to 3. Substituting into our alternate formula for the difference quotient, our formula becomes f of t minus f of a over t minus 1. So the numerator looks like t squared plus 2t from the f of t, subtract the 3 from f of 1, and we have that t minus 1 in the denominator. Unlike our other difference quotient, we don't see a lot of simple cancellation in the numerator, and it isn't necessarily obvious how this t minus 1 comes out of the denominator until we look a little bit more carefully at our numerator and notice that this is simply a polynomial that is factorable. So this polynomial factors into t minus 1 times t plus 3. And remember, we can check that we got the right polynomial by looking at our mixed terms. So minus 1 times t is minus t, and t times 3 is plus 3t. So minus t plus 3t gives us this 2t here in the middle. Now it's easy to see our cancellation, t minus 1 in the top, t minus 1 in the bottom. So our difference quotient becomes t plus 3. But remember, this is only valid where t is not equal to 1. Now, our other form, or earlier form that we used for the difference quotient, looks like f of x plus h minus f of x over h, where h was not 0. Again, being careful not to divide by 0. And we actually looked at this exact function earlier, f of x equals x squared plus 2x, at the x value of 1. And that difference quotient gave us h plus 4 when h was not 0. So we want to see how these two different values relate, this h plus 4 and this t plus 3. So how are we going to do that? Well, first, if we think about the fact that these are both giving us the slope, we need to have that these denominators represent the same thing. So we're going to let h equal t minus a. So in this particular example, that means h is equal to t minus 1. So what does that do for our formulas here? T plus 3 and h plus 4. Are we taking the same difference quotient? We see that h plus 4 using the substitution is t minus 1 plus 4, which is t plus 3. So this x equals 1 is like this a equals 1 value. So we see that we can let x equal to a. And if we do that using this substitution, x equals a and h equals t minus a, we can see what happens to our difference quotient. So f of x plus h minus f of x over h, replace all the x's with a's and all the h's with t minus a, looks like f of a plus the quantity t minus a, subtracting f of a, dividing all by t minus a. So right now the denominators definitely match in my new simplification, and a little bit more work in the numerator will allow me to see that these are indeed the same formula. Notice in this first function, this plus a at the beginning and this minus a cancel, leaving f of t minus f of a over t minus a. So the quotients formulas actually match, but what about our restrictions? So let's look at that. Remember, for our earlier formula we looked at, we needed h not equal to 0. Well, remember, we're making h equivalent to t minus a, so this h not equal to 0 becomes t minus a not equal to 0, and another way to write t minus a not equal 0 is to write t is not equal to a. So we see that we actually have equivalent formulas between these two definitions listed here on the top.